We thought we knew just how big the universe was. It revealed 10,000 galaxies in a tiny, seemingly empty patch of sky. This single image became the cornerstone for estimating that our universe held a staggering 2 trillion galaxies, and completely missing everything hidden by cosmic dust or redshifted into invisibility. Now, the James Webb Space Telescope has shattered those old boundaries, and what it found was breathtaking. Not 10,000 galaxies, but nearly 780,000, stretching back 13.5 billion years into the dawn of time. The universe isn't just bigger than we thought. The very rules of its formation seem to have changed. How could so much structure, so much maturity, appear in what we once thought was an empty void? This is the story of how the JWST just redefined the true scale of our universe. Let us rewind to 2004. Astronomers pointed Hubble's gaze toward a dark sliver of sky in the constellation Fornax and just let it stare for over 11 days. The result was the Hubble Ultra Deep Field, an image that became an icon of modern astronomy. What looked like a blank canvas was suddenly filled with nearly 10,000 galaxies. Each pinprick of light wasn't a star, but an entire island of billions of stars, some shining from over 13 billion years ago. For years, this was our best map of the distant cosmos, a profound window into the universe's childhood. It was a humbling realization that nearly every point of light in the image was a galaxy, each with billions of its own suns. This meant that the most ancient galaxies, whose light has been stretched by the relentless expansion of space, had faded into the infrared spectrum, far beyond what Hubble could see. On top of that, vast clouds of cosmic dust acted like a veil, obscuring entire populations of galaxies from our view. So the Ultra Deep Field, as detailed as it was, represented just a tiny slice of reality, shaped by the limits of its own technology. The universe, it turned out, was hiding far more than we ever realized, waiting for a new kind of eye to pull back the curtain. And that new eye is the James Webb Space Telescope. Webb isn't just a bigger version of Hubble. It's a completely different kind of observatory. Its massive primary mirror stretches 6.5 meters across, dwarfing Hubble's and collecting more than 6 times the light. But the real game changer is what it sees. Webb is tuned to the infrared spectrum. This allows it to pierce through those obscuring clouds of cosmic dust and catch the faint, stretched out light from the earliest galaxy's light that was completely invisible to Hubble. Where Hubble peered through a keyhole, Webb has thrown open the doors to a grand ballroom. To give you a sense of this incredible leap, imagine the Hubble Ultra Deep Field as a photograph printed on a single sheet of paper. To capture the same depth of detail, the Cosmos Webb survey would fill a mural 13 feet tall and 13 feet wide. This monumental project used over 250 hours of Webb's observing time, meticulously scanning a patch of sky about 3 times the area of the full moon. Thousands of individual exposures were then stitched together to create one seamless mosaic, the largest and deepest panoramic map of the universe ever made. Within this single enormous field, astronomers have already cataloged nearly 780,000 galaxies. Some of these are shining from less than 400 million years after the Big Bang. This isn't just a bigger picture, it's a whole new kind of atlas. It's deep enough to reveal the universe's faintest, oldest structures and wide enough to show the grand architecture of cosmic filaments, clusters, and the vast voids that separate them. For the very first time, astronomers can study not just isolated galaxies, but the entire sweep of cosmic structure across billions of years, all within a single, continuous frame. Webb's infrared vision and its sheer reach have given us a new window into the universe, transforming our understanding of both its immense vastness and its hidden depths. Within this vast Cosmos Webb mosaic, the nearby universe snaps into sharp focus, revealing a realm of mature galaxies, tangled cosmic mergers, and colossal superstructures. Here we see galaxies in their prime, grand spirals, smooth ellipticals, and irregular, chaotic shapes caught in the middle of spectacular collisions. The sheer scale of this map allows researchers to trace how these galaxies gather into titanic filaments and clusters. forming the very backbone of the cosmic web that spans the universe. Yet, among all these familiar shapes, one incredible discovery stands apart, a system known as the Infinity Galaxy. This extraordinary object, seen as it was about 7.6 billion years ago, reveals a stunning figure-8 silhouette. It's the result of two disk galaxies colliding almost head-on. In the image, you can still see each galaxy as a compact reddish core, circled by glowing rings of stars and gas, their orbits twisted and warped by the raw force of their encounter. This collision, which is estimated to have happened about 50 million years before the light reached us, is more than just a spectacle of cosmic violence. It has created conditions that we've never been able to capture so clearly. Between the two galactic centers lies a vast cloud of ionized hydrogen, glowing with the energy of a hidden engine. Using both JWST and the Chandra X-ray Observatory, astronomers pinpointed the unmistakable signature of a supermassive black hole, but it wasn't in either of the galactic nuclei. It was lodged in the space asterisk between asterisk them, embedded in the swirling gas. This off-center black hole, weighing in at about 1,000,000 times the mass of our Sun, isn't alone. Each of the original galaxies harbors its own active supermassive black hole, confirmed by their telltale hydrogen emissions. This creates a striking configuration: 3 hungry, active black holes, but only one is floating outside a galactic core, nestled in the chaotic aftermath of the merger. The evidence suggests it formed right there, collapsing directly from the dense, shock gas funneled by the collision, rather than being ejected from one of the galaxies. The Infinity Galaxy is a testament to the power of Webb's panoramic view. Only by surveying such a wide and deep field could astronomers hope to spot such a fleeting, complex event. Its unique figure-8 form, with a black hole growing in the void between worlds, hints that the universe's most massive engines might sometimes ignite not in the hearts of galaxies, but in the turbulent spaces where they collide. As we journey deeper into the cosmos web mosaic, we're finding that the universe is not only bigger, but far more creative and surprising than we ever imagined. Imagine peering back in time, not just a few years, but billions. We're traveling to a period astronomers call cosmic noon, about 10 billion years ago. This was supposed to be the universe's busiest factory, a time when it was churning out new stars at an incredible rate. The galaxies here weren't just energetic. We expected them to be messy and chaotic. But the James Webb Space Telescope is showing us something entirely different. It's revealing galaxies that are surprisingly organized, displaying a level of maturity that simply shouldn't exist so early. Webb's powerful infrared vision has uncovered a startling contradiction. We're finding galaxies that have already stopped forming stars, what we call quenched systems. These galaxies are abundant at a time when theory predicted they should be ablaze with stellar birth. Think about that. Enormous dormant giants, some as massive as the largest galaxies in our modern universe, just sitting quietly. They exist in a cosmic landscape that was supposed to be dominated by youthful frenzied systems. It is like finding a fully grown ancient oak tree in a field where only saplings should be sprouting. But the surprises don't stop there. Webb has also spotted beautiful spiral galaxies with perfectly defined arms, their disks stable and symmetrical. And these aren't in our cosmic backyard. We're seeing them at redshifts between 2 and 3, which means their light started its journey just a few billion years after the Big Bang. Conventional models told us it should take much, much longer for the universe to build such elegant, ordered structures. Yet, here they are. We can see spiral arms winding gracefully around dense cores, and some of these galaxies even have central bars, a clear sign of a settled, mature disk. The data is undeniable. The building blocks for these complex features were common far earlier than anyone anticipated. This early sense of order isn't just about pretty pictures. The presence of stable disks and these giant quenched galaxies at cosmic noon forces a major rethink. It means the process that shut down star formation and shape a galaxy S structure must have operated with incredible speed and efficiency. The entire timeline for building complexity in the universe is shrinking before our eyes. Each galaxy from this era becomes a crucial piece of evidence, forcing astronomers to reconsider just how quickly the cosmos can leap from chaos to order. The map of our universe isn't just getting richer. Webb is fundamentally rewriting the rules of how galaxies grow up. Now, let's push even further back, to the very edge of what Webb can see. But the real shock comes from what's inside these infant galaxies. Astronomers have detected oxygen in JHC SC140. Oxygen is a heavy element, meaning it's forged inside stars and scattered into space when they die. Finding it this early is evidence that at least one full generation of stars had already lived, died, and enriched its surroundings within the first 300 million years of the universe's existence. These galaxies are incredibly bright, shining with the light of hundreds of millions of suns packed into tiny, intense starbursts. Their mere existence and their chemical fingerprints suggest that galaxy assembly and stellar evolution began at a speed that completely defies the standard cosmic timeline. The discoveries flooding in from Webb's new map are forcing us to tear up the old textbooks. We now know that both galaxies and the supermassive black holes at their centers formed earlier and grew faster than any of our models allowed. The standard cosmic timeline once depicted a slow, gradual march from simplicity to complexity over billions of years. Now, it looks more like a rapid-fire sequence of assembly and transformation. What we thought was a slow billion-year process seems to have been compressed into a cosmic sprint. The pace of cosmic reionization, the growth of massive dark matter halos, the seeding of black holes, all of it demands new explanations. The first chapters of the universe's story are being rewritten as we speak, and the questions Webb is raising will drive astronomy for decades to come. To give you a sense of scale, in just 250 hours of observation time, the Cosmos Webb survey mapped nearly 780,000 galaxies. That is almost 80 times more than the Hubble Space Telescope's legendary Ultra Deep Field revealed back in 2004. This incredible infrared panorama exposes structures stretching back 13.5 billion years, including those record breakers we just talked about. The data shows that mature spirals, massive mergers, and heavy elements appeared far earlier than we ever thought possible. And yet, for all that we've learned, key questions remain. How did galaxies and their black holes grow so massive, so quickly? What roles did dark matter and cosmic feedback processes play in this accelerated evolution? Every new observation is rewriting the timeline. And it's important to remember, this revolutionary map covers just a tiny patch of the sky. It's a profound reminder that our universe is vastly larger and more complex than we ever imagined. The greatest discoveries may still be out there, waiting to be found. Thank you so much for joining me on this incredible journey to the dawn of time. If you found this as mind-blowing as I did, please hit that like button and be sure to subscribe and turn on notifications so you don't miss our next cosmic adventure. See you in the next video.